Hello and welcome to Algebra. Today we're going to look at a new grouping method for factoring. This is when we have polynomials, 4 or more terms. We'll focus on 4-term polynomials. First of all, what is the factored form of the following? What we're going to do is we're going to go through and group the first two, group the last two, and see if there's anything in common. Now, what we're going to do is look back at some old methods. For example, if we had x plus 1 onto x plus 3, we had a version where we could multiply these by stretching out the x plus 1 and giving an x plus 3 to each. And then we would continue to distribute. And we're going to need to remember this and come back to this when we do this factoring by grouping, because that's basically what's going on. Before we knew what FOIL was, the shortcut, we had to stretch this out, and we gave 1 to each, 1x plus 3 to each. So we're actually going to go backwards. We're going to go from this form to this form in this example. Now, every time we need to look for a GCF that's in common with everything. I see a 3 in common with these, but not with the 2. I see a 2 in common with these, but not with this. And there's only an n with the first 3 terms. So there's no GCF for the whole thing. Now, this is the long method, but I think this is helpful. What I'm going to do is I'm going to break it into prime factors. So 3 times n times n times n. And then I'm going to say plus negative 1 times 12. Let's see, 12 is 2 times 6. 6 is 2 times 3. So it's 2 times 2 times 3. And then there are 2 n's. Then plus 2 times n, short factor list there. I'm going to say plus negative 1 times 8 is 2 times 4, and 4 is 2 times 2. So 2 times 2 times 2. And what we're going to do, the reason that's helpful, is that now I can go through and see very easily what they have in common. Look at the first 2. I see that there's a 3 in common and at least 2 n's. So n squared. What I'm going to do is I'm going to cross these out. The 3 is in common, and 2 n's are in common. And I'm left with this n and all of this. So what's left over, I put in parentheses. N plus negative 4. And instead of saying plus negative 4, I'm just going to say minus 4. Now, what do I see in common with these? I see that there's a 2 in common. I wouldn't write a negative here unless I had a negative 1 in common. 2 is in common, and there's nothing else. So write a parentheses. I have this that's left over. So I have n plus a negative 4, or I could just say minus 4. So we're going to pull these out, and then we put the leftovers, 3n squared plus 2, in another binomial. And that's my answer. We can check this. So first, outside, inside, last. And you notice that gives us the original. Let's try another one. What is the factored form? We're going to factor completely. And the first thing we want to do is to go through, you could just divide it, it's sort of a shortcut, or you could go through the prime factors. That's what I'm going to do. So 2 times 2 times 1, 2, 3, 4. I can say plus negative 1. 8 is 2 times 2 times 2. There's 3 q's. Plus 2 times 6. 6 is 2 times 3. And 2 q's. And then plus negative 1 times. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. And we have 1 q. So now we're going to look through, even though that looks a little messy, what that's going to do for us is get an advantage in being able to see a little bit more clearly what's going on, especially when we start off. It's kind of like a training wheels. So we see, is there anything in common? Well, I notice that everything has a 2. In fact, everything has 2 2's, and everything at least has 1 q. So I'm going to pull out 1 2 2's. 2 times 2 would be 4. And then I'm going to pull out 1 q from each. So we have 4q. Now the leftovers I'm going to write inside. So we have 1, 2, 3 q's, q to the third. Instead of plus and negative, I'll say minus 2q squared plus 3q plus negative, instead of plus and negative, we'll say minus 6. So this is a little bit easier to see what's going on than this is, but we're actually going to reuse this prime factorization. I'm going to list the 4q and put big square brackets, so we won't forget that those are there. And now I'm going to look and see what's in common with the first 2 and the last 2. We're going to do our factoring by grouping. So we're going to group the first 2 terms and the last 2 terms. Now what's in common with q to the third and 2q squared? Well, I notice there's 2 q's. And the second time that I'm going to cross these out, I'll go this way. So I have 1 2 q's, so that's q squared. I'm going to cross out 1 2 q's, 1 2 q's. Now what is left over that's not crossed out? We have a q. Instead of plus and negative, we'll say minus 2. Okay, let's look at, so q minus 2. Now let's look at these two. Let's group these together. I see 3q and negative 6. I notice they both have a 3. And since they don't both have a negative, I'm just going to say a positive 3. If there were a negative 1 here and a negative 1 here, I would pull out a negative 1 with it. So this is 3. I cross it out sort of the other way, so I know that was the second round. And what do I have left over? Well, there's a q here, and I'm going to say plus a negative or minus 2. So q minus 2. So write this over again out front. And I'm going to pull, since these match, now those have to match for this to work, these go into one parentheses, and the leftovers, q squared plus 3, those go into another. Now I think this is my answer, but I do need to be double sure, extra sure that I've actually factored everything out. Now, these two are both binomials, they're 2 terms. And what I want to look for is, do we have either a GCF or do we have difference of 2 perfect squares in either one of those? Here, I don't have a GCF. Do I see the difference? Yes. But 2 is not a perfect square, so we don't have the difference of 2 squares. What do I mean by difference of 2 squares? For example, x squared minus 9. That's a perfect square, and that's a perfect square, and we have subtraction, or difference. So it's the difference of 2 squares. If that's the case, I can break it apart. X plus 3, x minus 3. And if that happened in my answer, I would have to have another level where I break them apart again. When am I done breaking all of them apart? Well, it's like building with Legos. If you have a little Lego building, you build with all the Legos, put them all together, and then when you're done, you pull all the little Legos apart. Well, you're done when you've pulled everything apart that can be pulled apart. And in this case, this is not, it doesn't have a GCF. It's not the difference of 2 squares. In this binomial, there's no GCF. There's nothing in common, no factors. And it's not the difference of 2 squares. It's the sum. And 3 is not even a perfect square anyway. And that can't be factored at all. There's not even addition or subtraction. So we are done. And you could check by doing FOIL method on these two. And then once you've done FOIL, distributing a 4q onto each of those 3 terms. Okay, now this one we need to break down also, so it gives us another chance. And for this one, I'm going to do it sort of the shortcut. You notice on these, we did the prime factorization. Once you get used to this, you can just divide through by what you see. So you can just kind of look at it and you see what are common factors and divide those out. So first of all, do I see anything in common with all 4 of them? Well, I notice that 2 divides into all of them. I also notice that there's at least 1d in every single one of these. So we have 2d. Well, 6d to the 4th divided by 2d is going to be 3d to the 3rd. 4d to the 3rd divided by 2d. 4 divided by 2 is 2. d to the 3rd divided by d to the 1st is d squared. Negative 6 divided by 2 is negative 3. D squared divided by d is d. Negative 4 divided by 2 is negative 2. D divided by d is 1, so I don't even need to put it. So I pulled out the GCF. Now I want to look at the first 2 and the last 2 and see if there's anything in common. I'm going to put the 2d on the side with some square brackets so I have a little room to work. Now what's in common with these? Well, there's 2d's, but there's no other coefficient constant. There's no other numbers. So between 3 and 2, there'd be just a 1, but I don't necessarily need to write that. So 3d to the 3rd divided by d squared, that would be 3d. 3 divided by 1 would be 3. d to the 3rd divided by d to the 2nd. When you divide like bases, you subtract the exponents. And then plus d squared divided by d squared is 1, so there's no variables there. 2 divided by 1 would be 2. In this one, I'm going to do it wrong to begin, and then I'll show you what the fix is. Some students will just look through and say, you know what, there's nothing in common, so I'll just say plus 1. And that's negative 3d minus 2 left inside. You notice these don't match. And the reason they don't match is because these are both positive, these are both negative. Well, you can think of it in a way as they both have a negative in common. Well, if they have a negative in common, you can pull that out and divide each by a negative. That's what I'm going to do here. I'm going to divide by negative 1, pull out that negative 1, and that makes negative 3 divided by negative 1 is a positive 3. D divided by 1 is still D. Negative 2 divided by negative 1 is 2, and so now these do match, so I can pull these out. So 2D, these combine into one parentheses, into one binomial, so 3D plus 2. And then the leftovers, d squared and negative 1, they're pulled into their own binomial. Now I think this is my answer, but I need to double check. Have I pulled apart, you can think about the Lego building, have I pulled apart all the Legos into their pieces? Well, 3D plus 2, is there a GCF? No, other than 1, there's not a GCF. Is it the difference of 2 perfect squares? Well, you've got addition, so it's definitely not the difference. What about this? D squared minus 1. Well, we do have a difference. It's subtraction, d squared minus 1. The front, the leading term, d squared, d times d gives me d squared. The 1 times 1 gives me 1. So I have 2 perfect squares, and I have subtraction. Excuse me. So what I'm going to do, what times itself gives me d squared? D. What times itself gives me 1? 1. So this is going to be d plus 1, d minus 1. And that will be the difference of 2 squares. Look in the last lesson, 8-7, and we give a little bit more detail on that. Pull down the 2d, pull down the 3d plus 2, and we need to double check. Is there a GCF? No. Difference of 2 squares? No, it's addition. GCF? No. Difference of 2 squares? Well, this is a square, but that's not. GCF? No. Difference of 2 squares? No. And this is not going to be factorable again. So this is my final answer. How could you check? Well, it'll take you a little while. You'd have to FOIL this, then multiply by d plus 1, and then finally multiply everything by 2d, and see if we get the original form back. That is the correct answer. Alright, so you may want to pause this, write it down, take a screen capture, whatever you need to of this. This might be helpful. The first thing you do for any of these is find that GCF. So if you find the GCF, you're looking for, is there a common number? You can break into its prime factorizations if you're having a hard time visualizing. If there's a number or a variable that has each of those terms, it's in each of those terms, then you're going to pull it out, you're going to divide by each term, and that pulls out the GCF. That's going to be very important for some of these problems, especially if we get difference to squares and those kind of cases, because it may mess you up. Once you found the GCF, if there's two terms, it's a binomial, then you're going to look for the difference of two squares, the a squared minus b squared. We had that in the last problem. If it's three terms, we're going to look for a perfect square trinomial or just any normal trinomial. You're going to use the box method. Some students like using the grouping. We talked about that in our 8-6 lesson, but it's more common for us to use the box method. If there's four terms polynomial, we're going to use the grouping method. Grouping method, you look at the first two, you look at the last two, and that was this lesson. Look at the first two, look at the last two, pull the GCF out of each one of those, and then see if those parentheses match. And if they are, you can pull them in together to be one. So this flowchart sums up what we've done through 8.5 through 8.8. 8.5 was the simple perfect square trinomials. 8.6, the more advanced, or excuse me, not perfect square. 8.5 was the simple trinomial factoring. 8.6 was the factoring trinomials with a leading coefficient that's other than 1. 8.7 was the special cases, and 8.8 was the factoring by grouping. So as you go through those, you will need to use this flowchart. That'll do it for today. Hope you have a wonderful day. Take care.